Hello everyone. In previous session, we discussed about what is the introduction of backtracking algorithm and some of the problems regarding backtracking algorithm. That is NQ's problem and coloring of a graph and some of subset problems. These are all we have discussed. Today, I am going to discuss a new topic called Hamiltonian problem. This is also regarding a backtracking concept only. Today, in this session, we discussed about what is Hamiltonian problem, how to solve a Hamiltonian problem. This topic is called as a Hamilton cycle. In this video, we will learn what is Hamilton cycle. Then I will show how to use a backtracking algorithm in this concept, and also I have to explain the algorithm to start how to use this backtracking concept in this directed graph or undirected graph. First of all, let us understand what is Hamilton cycle. Then later we discussed about that problem regarding that backtracking concept using a Hamiltonian cycle. See, if the graph is given, then we have to start from starting vertex. We have to start from starting vertex and visit all the vertex exactly only one at a time and return back to the starting vertex. That forms a cycle. So we have to start with a source node and we have to visit all the nodes and return back to the same node. This is called as the main concept behind the Hamilton cycle. This concept come under traveling salesman problem and Dijkstra. So many concepts will appear in this Hamilton problem. Now we have to check that is there an Hamilton cycle is possible in a graph. Yes. If possible, then what is the cycle behind that? Now, if they have a multiple cycle, we have to find out that also. If we have a multiple cycle, so in Hamilton cycle, we have to find the different possible solution. If one possible, we have to start from source node 2 and return back to the same node. So not a single one, but it having getting the more solution in this concept. So this is the main concept behind Hamilton cycle. In previous traveling salesman problem, we'll get only one solution, but here we'll get the more than one solution in this Hamiltonian cycle. The problem is to find out there is a Hamilton cycle in a graph or not. This is the problem. We have to find out the Hamilton cycle or there in a graph or not. The problems look similar to the traveling sales. This problem is look similar to the traveling salesman problem. In traveling salesman problem or salesperson problem, also we have to start with same vertex and visit all the vertex and return back to the same vertices. But this is a minimization problem. Traveling salesman problem is a minimization problem. But here it is not a minimization problem. We have to travel. We will get the more than one solution in this Hamilton cycle. Here we have to find out the minimum cost tour. If you have a total cost of the tour, we have to find out all the possible tours. First, we have to start with source vertex as a tour and we have to return back to the same tour, and we have after getting once at a time and we have to return back to the same tour. We'll get the more solution in this Hamilton cycle. Before going to start a cycle, let's discuss about a definition of Hamilton cycle or Hamiltonian problem. The Hamilton path is a path in an undirected graph that visit each vertex exactly once. You have to each visit exactly once. If you have more than solution, we have to visit only one time at that node. If they do not mandatory, it should not be repeated that same node again. This is the main concept behind. Next, a Hamiltonian cycle is a cycle in an undirected graph that visits each vertex exactly once and returns to the starting vertex. Determining whether such paths and cycle exists in a graph in the HCP, Hamiltonian cycle problem. This is called as a Hamiltonian cycle problem. So this is the graph where we have to solve the basic example. After this graph, I will show some more example to find the Hamiltonian cycle. Let's see this graph. This is either this is directed or undirected, but you have to find out the Hamiltonian cycle. Hamilton cycle, we have to start with this node and end with a return back to the same node. But while traveling to the some other node, the node should not be repeat again. We have to repeat only once at a time. So this is the major concept behind Hamiltonian cycle. Let's see. Here we have to start with 1, next 2, next 3, 4, 5, 6, 1. Again it return back to the same node. This is the one example for Hamilton cycle. See, travel from 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6 and return back to 1. This is one solution. Next solution, 1 to 2, 2 to 6, 6 to 5, 5 to 4, 4 to 3, 3 to 1. See here, 1, 2, 6, 5, 4, 3 to 1. So this is another one solution. 1, 2, 6, 5, 4, 3, 1. We'll get another solution. We'll try for some more solution. 1 to 6, 6 to, sorry, 1 to 6, 6 to 2. Here, sorry, 1 to 6, 6 to 2, 2 to 5, 5 to 4, 4 to 3, 3 to 1 again. This is another one solution. 1 to 6, 6 to 2, 5, 4, 3, 1. This is another one solution. Next, similarly, we'll start with 2. 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 1 and again 2. See here, another one solution is there. 2, 3, 4, 5, 6, 1, 2. This is a no. This is not another solution. This solution is similar to the first solution. See here, we are starting with 1 to 1, but here starting with 2 to 2. But this looks like a similar. So this is not possible. Only 3 solutions will possible in this graph. Let's see for another graph. Let's see for another graph. This is 1. 1. This is 2, 4, 3, 5. This is one graph. Let's see here. 1 to 2, 2 to 3, 3 to 5, 5 to 4, 4 to 1. See here, 1 to 2, 2 to 3, 3 to 5, 5 to 4 and 4 to 1. This is one cycle. Next, 1 to 2, 2 to 4, 4 to 5, 5 to 3, 3 to 1. This is another one example to find out the Hamilton cycle. Now, we'll see for another one example. Here, another one Hamilton cycle example. 1, 2, 3, 4, 5, 6, 7. This is one. Yes, you have to travel with 1 to 2, 2 to 3, 3 to 4, 4 to 6 and 6 to 4. If you travel 6 to 4 means it will not reach 5. So it is not possible for moving a cycle. So this is not an Hamilton cycle. If you travel 1 to 2, 2 to 3, 3 to 7, 7 to 6 and 6 to 5 and again you have to come back to 1 only. But 4 is missing. If you go to 4 then 5 is also missing. So it is not possible in this case. This is not a Hamilton cycle. Next, I will show another 2 examples. 1, 2, 4, 3, 5, 6. This is not also not possible, because if you travel from 1 to 3, 3 to 5, 5 to 6 and 6 to 3, again you have to come for 3 only. It will repeat 2 times this node. So this is called as this is a junction node. This is called as a junction node. That is name is called as an articulation point. This is called as an articulation point, because if you travel from one node to another node, again you have to come for these 2 nodes, then it will be intermediate between them. So it is also not a Hamilton cycle. And I will show one last example. 3, 4, 5 and 6. Today I am going to explain this last example. This is called as an pendant vertex. This is called as an pendant vertex, because if you travel 1 to 3, 3 to 4, again 4 is intermediate, it will not connected any graph. So it is also a Hamilton cycle. So these are the best example for Hamiltonian problem. For next class, I will discuss about how to solve a Hamiltonian problem using a backtracking method. These are all for the today's class. For next class, I will explain Hamiltonian problem. Thank you one and all. For more updates, please subscribe my channel.